Okay, today we're going to talk about the scientific method. There are four parts to the scientific method. You got your defining your problems, hypothesis, experimentation, and conclusions and validation. Now let's talk about each one. Now, here, defining your problems is where you're asking your question: why does this happen? When does it happen? How does it happen? What's happening? Where is it happening? Who is it? Whatever. Okay, any of your questions about science are happening here. Now, I have a few vocabulary words we need to go over. So, one thing we got to cover is quantitative data. Quantitative data is numbers. Qualitative data is without numbers. So, I mean, we can take quantitative data. That's what we usually are looking at, like averages, batting average, average yards after a catch for football. Uh, yeah, field goal percentages for basketball, stuff like that. Okay. Qualitative is the non-numerical stuff. So anything that doesn't have numbers, like, oh, I have blonde hair, my shirt has a blue collar, that kind of stuff is non-numerical data. So we do keep track of that stuff all the time, okay? And we can actually make it numerical if we want to. A blue shirt gets a 1, a red shirt gets a 2, okay? Stuff like that. So you can turn you can turn a lot of qualitative data into quantitative data. But, right, it's numerical versus non-numerical. So now generalize is just making, it's almost like most most people have it, or most, let's say most Marvel characters are heroes that we love, right? That's a generalization. When you don't love every single hero, I mean, maybe you do, I don't know. So that's kind of up to you. Generalizes most of whatever you're talking about has the quality characteristic or whatever. And skeptical, you're doubting things. So we've talked about we need to be skeptical about all the articles and things you hear in the news because a lot of them are lying to you and not telling you the truth about what the studies say. So anything time you hear a study says, you should probably be skeptical about it because it's not always true or what they're actually talking about. Okay. All right. Now, hypothesis. I jump higher when jumping off of one leg than off of two legs. This is a testable statement. I can jump off of one leg and see if I jump higher than when I jump off of two legs. Now, I'd want to make this a little more specific, like when I'm standing still, because if I'm running and then jump off of one leg, I'm going to jump higher than if I'm just standing still. So you want to be specific about it. Now, what a hypothesis is a prediction or assumption of what is going to happen, but you want to write it as a statement instead of, oh, I think this is going to happen. No, it is going to happen. So I jump higher when jumping off of one leg than off of two legs. It is going to happen. You write it in present tense, not it will happen, or if I do this, then this will happen. Yeah, it kind of works, but hypotheses are testable statements that predict what is happening in the experiment. So, yeah, a prediction is guessing what's going to happen in the experiment. Usually in science, we're using data, so a prediction and an assumption are kind of similar. Prediction, we're predicting the future, right? What's going to happen. Assumption, we're kind of just, uh, we have some data, so we're guessing what's going to happen, right? Both of them, you're using data, and yeah, so I assume that if you dress like a skater, you skate. But that's not always true, but a lot of times it is. So it's a generalization about dressing like a skater. I mean, it, right? Assumptions kind of, in science, we're using evidence. So make sure you have a little evidence behind your assumptions and predictions. All right. Now, experimentation. Oh, better move this. All right, experimentation. we have to design experiments in science. You have to design it to have replicability. Now, what replicability means is you're writing it well enough to where somebody else could replicate or duplicate or do your experiment. So I always think of a replica, so like a statue, like let's say the Vince Lombardi statue. So Vince Lombardi statue is the trophy they give out to every Super Bowl winning team. Now they make an actual statue, but then they make little replicas that are like this big, right? Now we want to replicate our experiment, but we don't want it to be this big. We want it to be the normal size. If it's going to be a true replica, you want it to be the same as it was before. So you need to be precise about how you're explaining your experiment and what you're going to do. Now, the reason for the gecko was in college, I was in a class where we had to do an experiment with animals. I couldn't hurt them or anything. So I wanted to know if they would get accustomed to a stimulus, like a tap on their cage every day, if I did it at the same time every day, because humans, we wear a hat all day and then our head still feels like it's wearing a hat, or we lose our hat because we forget it's there because our head and hair are just so used to it being there. So I was like, oh man, I bet you if I tapped on their cage, they'd be scared at first, and then they would eventually get, used to it and they'd stop getting scared. So I had to write my experiment in a precise manner so that I could be, I could get my geckos and start my experiment. So we need to use precision so that we can replicate the experiment. So in my experiment, I had different variables. I had too many. That was the problem with my experiment. But in all controlled experiments, you want control. You want a control, so something you're comparing the independent variable to. So we're comparing the independent variable and the control. An independent variable is the change you're making in the experiment. So let's say I want to use protein. So protein makes me gain 2.5 pounds per month while doing a weightlifting program. So adding the protein is what's making the difference. That is the independent variable. Now, the dependent variable is dependent upon the independent variable. So that must be the weight gain. The weight gain. So I want to gain weight and I'm going to use protein to do it. Now a control for that would be, I'm just using some random powder and putting it in water, and it's nothing. It has no calories, nothing in it. So that would be your control. Or you could give them something that has the same amount of calories, so just no protein in it. So you got to compare your independent variable to the control. I like to say the dependent variable is what you're actually measuring. So each month, right, you get on the scale and weigh yourself. Okay, I gained 1.5 pounds. Well, it helped me gain 1.5 pounds. I did nothing else to my diet but add the protein. So yeah, I'm measuring that. That's the weight gain. Okay. So you could even do this for like something like cheerleading or dance or whatever. And you're going, okay, well, if I perform a harder routine, right? Performing a harder routine at state helps us get a higher score, because the harder the routine, the higher score you can get, which is nice. So you perform a harder routine, but then you'd also have to do, right, because you need something to compare it to, you need not as hard of a routine, an easy routine. So a hard routine and an easy routine, which one scores higher? And then you can kind of determine, did you do the same, right? Did you do them both perfectly how you wanted it to? If you did, then you'll get good results for your experiment. And the dependent variable is the thing you're measuring, the score. Okay, so let's move on. My independent variable was actually, I set the time at the same time every day. I went in at 9:55 and tapped on each gecko's cage that were in my experimental group. And then My dependent variable was to see if they would stop reacting or the lack of a reaction. So my control, I went in and tapped on the control group's cages at random times during the day. So I'd go at like 4 p.m. and then 11 p.m. And then on a different day, I would go at 8 a.m. or 6 a.m. just to tap on their cages. So that was my control, the randomness of it. All right. Now, if you haven't yet, I want you to do the example on page 10 in your notebook. So make sure you do that. It'll really help you out to kind of figure out how to find the independent, dependent, and control. Okay. All right. Now, conclusions and validations. Do you reject or fail to reject your hypothesis? I love how science does the fail to reject. Let's do a double negative. So, if you fail to reject, then, you were right. It's just funny. So, vocabulary, we have inference, relate, and interpret. So, interpret, we're looking at the data and deciding what it actually says, right? That's interpreting. We're deciding what it says, right? Just like an interpreter for a language. Okay, they listen to somebody speak Spanish and interpret it and make it into English. There are a lot of different Spanish words that have like kind of a double meaning, and it is kind of hard to translate. So, all right, inference is a type of conclusion where, okay, well, my conclusion actually for my gecko experiments was that I rejected my hypothesis. That they didn't, I rejected my hypothesis. Now, my inference is geckos just don't react because they never reacted. Geckos just don't react. They don't have, I don't know what happened. So let's say protein, the protein, it helped me gain 1 pound a month, but it claimed to make me gain 2 pounds a month. So my conclusion is I gained 1 pound per month, so it does work a little bit, but their claim, my inference, would be, gosh, this stuff doesn't work as well as they said it did. Right? I'm inferring, I'm just saying, hey, this doesn't work as much as they said it did. Right? So relate, well, we relate everything in science to something. So the reason my geckos didn't react was it could have been related to the fact that I opened the door to the room they were in and the lights turned on. Right? That could have a correlation or relationship. So that was really frustrating. That was an extra variable that I didn't consider and I didn't know about before I put them in the cages and put them in the little basement room they were in. So everything's related, right? There's a relationship, so there's a bond between them. All right. And Monty Python, they go through the scientific method. And that's the basics of the scientific method. If you have any questions, make sure you ask.